Hello, how are you? Displays, mirror. Bear with us for a second. There are two of us here on stage, and we are very happy to be here. I'm more happy than Quora, probably. Oh my God. Yeah. No, what
Hello.
is it?
It's on.
Yes, it's there. I see it. Wait, mirror.
I had a moment of panic because I thought we were going on at 2, and I started. So if you were asking me something and I ran away from you at 5 seconds to 2 o'clock, please approach me again and ask me. But I saw the slide that said Oded was presenting, and I thought that I had been removed from this one, and it just said Oleg because I was too late. So
Right.
thankfully that wasn't the case.
That's a
So
great
yeah,
story.
Introduction to test containers.
Introductions to Testcontainers. Very happy to see all of you here.
Who uses test containers? Okay, cool. All right.
Very good.
About a third, right?
Plenty of people who have heard of Testcontainers, but never actually use it. Okay, very good, very good. You are in the right place. Great. We are just in time. Okay, great. Let's go.
So I'm Cora Iverclyde. I spoke to you a little bit earlier about Gateway, and happy to be here with Oleg.
Yeah, and I'm not working on the Spring team directly. I work at a company called Atomic Jar. We are maintainers of the Testcontainers libraries. And yeah, I'd be happy to answer all of your questions about specifically Testcontainers or in conjunction with Spring or anything like that. So this is going to be a fast-paced session. We have a ton of material. We're going to try to cover that. And if you have any questions, shout. And if we feel that the question is better answered after the presentation, then we're going to do that in a very graceful manner. But please make it interactive, as interactive as possible. So before, in the morning, Sean was talking about a very important point. Better software is better than worse software, which is universally true. Do we know how to write better software? There is one thing that universally is known to produce better software, is tests. When we test our software, it tends to be better, which is very, very interesting. Right? So we're going to talk about tests. In the past, most of the developers had a sort of this idea, this picture in the head. How do we organize the tests? We're going to have a ton of unit tests. We're going to make unit tests the base of our test suite. We're going to test everything in isolation. We're going to limit how we do things. And then on top of that, we're going to build the integration tests and end-to-end tests. And we're going to struggle with maintaining them and running them in a repeatable manner. And this is what we did in the past. And nowadays, specifically with migration towards microservices architectures and with our application getting smaller and smaller, the importance of integration tests is growing. So when the application is small, there is not so much business logic, the implementation detail to test with unit tests. And sort of the behavior of the larger system is encoded in how our components interact like in a larger system. So integration tests are getting more and more important, and different teams are trying to rethink how they structure the shape of their test suites. And the honeycomb image is from a blog post by Spotify from a few years back, and they do know a thing or two about microservices. So yeah, integration tests are more and more important.
Yeah. So I think over time, depending on how long you've been doing this, you have maybe come across all of these approaches for integration testing. But it's hard, right? Integration testing implies that you have a system to test against, right? The system you're integrating with. So, I'm old enough to remember relying on just an operations team when that was almost the only option to provide a DB2 database that people could test against, something like that. Or, sometimes you have a system like install your little local Oracle XE on your local machine and you manage that, right? That would be a little bit easier approach. You don't have to rely on operations team. And then as time progressed, in-memory solutions became popular. And generally, within memory, we're generally talking about things like databases with H2 or HSQL or maybe a mock server for HTTP requests. And now, with as Oleg is saying, with the era of microservices and containerization, you have containers that you can start to test against, which makes things easier than all of that. But still, and you're still managing the lifecycle of the container. You're still choosing the container and maybe using something like Docker Compose when you get to the point where you have to start up many containers. But the onus is still on you as a developer to manage all of this. So even though things are getting better, things are still a little more complicated than we would like. So actually 8 years ago now, the screenshot's a bit old, someone by the name of Moshe Eshel created a gist in which they proposed using a JUnit rule to automatically start up a container and then feed the information about connections to the container into the test and automatically test with it. So this was a great idea. So what if this, was sort of codified into something reusable, right? What would we need? So you would need something that would manage the life cycle of the containers, right? Starting, connections, cleanup, everything like that. Do all the configuration that you need for the particular system you're testing against, and then maybe integrate into the framework that you're working with, aka Java, Spring, et cetera, right? Maybe other languages. And in fact, this gist was the inspiration for what the project the test containers project that was created. And so in the comments of the gist, you see that it is superseded about a year after the gist as test containers.
Yeah, and this is how test containers was inspired. And what it is, test containers in general is a collection of libraries, open source libraries in different languages that integrate with Docker on one hand and with your programming language or your application framework on the other. Testcontainers Java is the original implementation of this approach. It was created 7 years ago, very sort of rapidly after that GIST inspired that. For the record, if you think 7 years is not like a very mature time in Java years, that's a lot in Docker years. Docker was just a very, very young project back then, when the idea that there should be a library that will allow you a programmatic control over the containers, because that's what the tests require. That's what when it was born. Test containers uses the Docker API, so it doesn't rely on the availability of your command line Docker thing. It doesn't run the Docker commands on your command line. It sends requests to the Docker daemon directly, and it integrates, on the other hand, with your application frameworks, in this case with Spring, and normally JUnit. How many of you run JUnit tests? Everyone should be. Other people do not run tests or use something like Spock? I hope you answer Spock, because it should be like brushing teeth, right? Like a very hygiene question. You should have been writing tests. So
if you don't write tests, Oleg will come after you.
No, not personally, but like it just makes no sense, right? And so test containers runs, and besides having integrations, it works with anything that runs in a Docker container. So that could be your databases, that could be your message brokers, that could be your headless browsers if you want to do UI tests, or anything. Nowadays, everything runs in Docker containers, so this is a pretty universal solution. And as I said, this is not just Java. So if you're working with different JVM languages, like Kotlin, for example, that would work very, very nicely with the Java version of the library. And even, I think, some of our usage of recursive generics inspired some advancement in the Kotlin compiler. So they are tracking the project and sort of using that on scale as well. But there are also implementations in other languages, right? So if you have less fortunate people at your workplaces, in your teams, who, for example, have to write in other languages, then there is Testcontainers Go, there are Testcontainers.net, there is Testcontainers Node.js. So everyone can take advantage of the approach, because it's pretty universal. And the second greatest thing, besides being available in different languages, is also that there is a growing ecosystem of modules, which are predefined abstractions, sort of the libraries that you can include in your project, and they will give you access and the programmatic API to spin up the services that your application might need without you actually knowing how to run those services in the Docker container. Like, for example, how many of you know how to run Kafka in a Docker container? So much. Unexpected. What about HiveMQ with extensions? Right, so you get the point. With the libraries, with the modules, you can just include the appropriate jar file, and then you will have the creation and the lifecycle configuration and everything at your fingertips. So this is great. This is great. And it's not just me working at Test Containers telling you how great Test Container is. Recently, this year, somewhere in March, the ThoughtWorks published the technology radar, where they put Test Containers strictly into the adopt category, and said that this, in their opinion, this should be the default option for writing tests and creating a reliable environment for the tests. Well, ThoughtWorks, if you are not convinced with ThoughtWorks, the start.spring.io recommends test containers as well. This is the top dependency. If you start adding the dependencies with the tests, so they're just there, and ThoughtWorks liked it. Oleg likes it. Start.spring.io likes it. So what's not to like? Maybe we can look at how it works and what's in there.
Yeah. So we'll go through a few demos. So, so as we said, it integrates with JUnit. So I'm going to show you a little bit about the container lifecycle, and then we'll move on. So the first demo is slides. A little easier. OK, so on the left-hand side, you see a typical test. So if you work with JUnit, you'll find this familiar. You'll see at the very top of the class, there's an annotation for @testcontainers. And then the very first object that's created is a generic container, a test container using the generic container type. And that is annotated with the @container. So basically, we're telling test containers that we want test containers to manage the lifecycle of the container that's annotated with @container. And then you have the usual annotations that define the lifecycle of JUnit. And so I want to highlight the places where test containers will participate in the JUnit lifecycle. So, so once you get to the before each, so you run your before all, that's just your normal code, whatever you put in there. But then before each test, before the code that you write that should run before the test, you're going to need a container, and you might need to do something in the before each before you run the test. So at that point, test containers is going to start that container for you, and you can see the first time it does a few more things. So it checks to make sure, is your Docker running, or does it have access to Docker, whether it's local or remote, right? If the Docker container isn't available, does it need to pull it? If so, it will pull it down, and then it'll start an instance. So when you get into the code that you've written in the before each, by that time you have a container. Then your test will run, no participation there. But then after each code runs, then test container steps in to do the container cleanup. It uses another container called React that has access, and that'll do the cleanup of the container, and it just removes it. So then when your second test runs, you're going to get a brand new container, and that can be a totally clean test. Unless you actually want to use the same container from test 1 in test 2, in which case all you have to do is make that object static, and then you can see the class instance ID is different, but the container instance ID is the same in both tests. So that's the integration with the JUnit lifecycle. So let me show you some other basics. We're going to talk about when you start up the container, accessing ports, accessing the logs from inside the container, right? You have the logs from your application, but what if something's happening in the container? And then some other things that you can do with it. And as we said, it supports any kind of Docker image. It doesn't have to support a Docker image that already exists. If you have a Docker file and you want to build an image and use that, then it supports that as well. So let's switch over to IntelliJ. And which one is this?
No.
OK, so connection test. Is that right?
Yes, I think so.
OK. All right. OK. It's always a little weird to use a different computer than the one you're used to. This one goes the other way. OK. So, all right. So we've got our class annotation, and we've got our container annotation. I'm going to be using generic container in my demos, and then Oleg will show you the specific modules that are custom for different services. And if you might notice from my gateway demo, I really like testing against this HTTP bin, really easy. And also, I know from the documentation on that HTTP bin, that website, the author of the website also provides that application as a container. And I know that when that application starts up inside that container, it listens on port 80. So I'm telling test containers to please download that image and start it up, and I'm telling it that the application will be listening on port 80. So in my test, I want to be able to connect to it. So if it listens on port 80, how about I try hitting localhost 80? And how many of you think that will work? Good. OK. Right answer. And so the reason that doesn't work, of course, is that that's not the container that's exposed through the container. That's not the port that's exposed on the container. That's just the port that the application inside the container is listening on. And since I'm asking, and so that fails, of course, right? It can't connect to port 80. There's nothing listening on port 80 on my machine. So really, what I have to do is I have to ask test containers, hey, you started this container for me. You dynamically mapped a port to that port 80. What port is that? And I might even need to get the host. So what I do is I go to the container object, I get the host, and then I get that first mapped port. In this case, there's only one. And then I can run that test, and that will work. So it's really alleviating me of all of the work of, pulling the container, starting it up, mapping a port, configuring this. It's all dynamic, right? So that's the first test. And, okay, so let's do the container logs. What's happening?
Just do
One.
Right.
Okay, thanks. All right. Okay, so now what if I'm running a test, and as I mentioned, something goes wrong inside of the container? How do I access the information from the service inside the container? So I have two choices here. So again, I'm using a generic container. In this case, I'm just going to use an image, just a regular, just to show you some other things that can be done, right? I'm just using it like an OS image. There's actually no application in there. So when this container starts, it doesn't do anything. So it's actually just going to stop right away. So there's going to be no long-running process there for test containers to check to see if it's ready or to run a test against. So what I want to do is influence a couple of things. Number one, I want something to happen when that operating system container starts up. So I'm going to set an environment variable, just a greeting. And then I'm going to intentionally, because we're going to explore logs here, I want to publish one line of logging to standard error and one line of logging to standard out to show you how you can differentiate between info and error logging. And then, because it is a short-lived container, I'm going to overwrite the default sort of startup check strategy that Testcontainers uses and tell it to use this one called one-shot startup, which is appropriate for this short-lived container. So at that point, I can go into my test. So the first way I can get the logs that have happened up to this point, for example. And the reason I would do that, just using container get logs, right, just the way we're doing the get port, get et cetera, we get the logs. And then I actually have the logs, and I can run assertions based on that log output. So I can do a test where I say, start that up, and if the logs contain this string, then I know that my container is successful, or that the service running inside of the container is healthy. So that's one option. And you can see that gets streamed out into the logs. It just kind of gets dumped right here. So here's a line for the assertion. And here's the line that we printed to standard error, for example, and it's just kind of dumped in there. Is that right? Did it run both tests? What am I looking at here?
What are you trying to find it?
I thought it would be not integrated with this log.
But you're logging. You're logging the lines.
Oh, we did it here. Sorry. Okay. Yeah. Sorry, we changed the code a little bit. Okay. So we are integrating it here. Okay, so we're doing it manually here, so it is integrated in here. But you don't have to do it that way. You can stream the logs, and then if you stream the logs, not only are you're not just getting a snapshot of the logs to that point, but you're continuing to stream the logs, and they'll be integrated into your log output of your application throughout the life. And that would be to do it this way, right? To basically follow the output using a log consumer, and then automatically it will be integrated into your with usually the prefix that you have into your logging. So those are two ways you can get the logs, and the first one, like I said, allows you to run assertions on it. The last thing I want to show you is a Docker file test. So here, let's say you have an application. So here we have in the temp directory, there's a hello world application, and there's a Docker file to build this. So this is the system I want to test against. So I want to build this and start it and test against it. So in this case, you can see, again, I'm using the generic container. I'm telling it the name to assign to the container once that container image is created, to assign to the image. I'm telling it where that Docker file is with a source. And then again, I can influence some build arguments. I can influence runtime arguments. I can expose more than one port if I like. And because I have to determine, I have to tell test containers to determine when this application is ready to test against, I'm using, in this case, I'm waiting for a log message to show up. So here, I just want to illustrate that in this case, we're getting the first mapped port, like we did on the first connection test. And that is successful. And on the second one, in order to hit a endpoint on that second map port, we specifically mentioned get the map port, and this was the second one that we had in the list. Oops. And that will also run successfully. And I think that's all. Am I missing something to?
Yeah, I think so.
So that's the basics.
Cora just showed how the lifecycle of the containers can be nicely integrated with the lifecycle of your JUnit tests using JUnit 5 extension and the annotations. Add test containers on the class, add container on the fields, and then the containers will be started and stopped according to your test rules. According to the lifecycle of your unit tests. You showed how to configure environment variables, expose ports from the container, and follow the logs if you need to, and that you don't even have to have those images pre-built somewhere available in the registry, but you can also run it and build the images from your tests themselves, and all without any configuration that is external to the tests, which is one of the best features, because as developers, you know how to work with your Java application, right? So here, all the configuration is Java. And could be Kotlin or something like this, right? So let's go. Where was it? The slides. So we're going to show a little bit more demos. And because this is obviously you're more interested in Spring than anything else, we're going to show a little example of some tests in an actual Spring application. So to give you a look and feel how the application with the integration tests with test containers can look like. And then we're going to cover, or at least mention, the following topics. We're going to look at the test containers modules and how they simplify creating those ephemeral environments. We're going to look how you can make your Spring application actually use the containers that were created, because it's not enough to create a database somewhere in the container. You also need that your application under test knows that database is there to connect to that so it can work efficiently. We're going to show you how to initialize and configure services within those containers, or at least a few typical patterns for that. How to initialize the database schema if you're working with a database. And we also give you a glimpse of the approach, how you can build some chaos testing practices into your test suites by using test containers and a little bit of creative programming. So we're going to use the same application, and this is a Spring application, right? So if this is a demo application, you can see there, it's a normal Spring application. It does nothing. Well, it does very little. It creates the controller, and it can access and receive HTTP requests. So the application deals with collecting feedback from the conference sessions, ratings to the sessions. The data model is not strictly speaking relevant, but what is relevant is that this application is using several external services that it needs for running. For example, it uses a Kafka template to send messages. And two classes in this application talk to each other via the Kafka, so send messages and listen to that. A little bit over-engineered, but a good sample application. It uses Redis to store a part of the data, so it uses the string Redis template to access that Redis, and it also uses and stores some of the data in the normal relational database and accesses that through the JDBC template. Why is it implemented this way? Because this application requires quite a sophisticated environment to run, right? So to run this application, I need to have my database somewhere, I need to have my Kafka, and I need to have my Redis. So to run proper integration tests that will exercise my application and check the sort of high-level functional tests whether my application can actually store the ratings that I sent to the particular sessions, I need that environment available in tests as well. So what's good here is that I have my demo application test, and I have my test and my test suite that does a bunch of things. So it's a demo application test. I can check whether my Spring context loads and whether the database is populated with some predefined data. I can check whether my actuator response was the health endpoint response was 200, so my application thinks that it's actually running in the configured environment. I have a test that also checks the high-level functional requirements. So if I post request to the /rating endpoint, I would assume that after some time, when everything will propagate through Kafka, I will get back the ratings for the same talk ID that I was testing, and that this would work, right? The request here library that we're using is Rest Assured, which is a great library with a DSL for doing like HTTP queries. Very, very good. If we don't convince you to use test containers, then rest assured it is another great library that you can use. And for waiting for the asynchronous events in tests specifically, or like in general, awaiting for the events, the library called awaitility is a very, very solid choice. We use that internally in test containers quite a bit for waiting for certain events, like waiting when the container is started, waiting for a certain log line appear, or that the ports are open, because, well, it's not even enough just to start the container. Because Docker can say, like, oh, my container is started, but the database in the container maybe is not ready to serve the your queries, and then your tests will depend on some like external factors, like, oh, did my database manage to start or not? Which would not be great, because what you want from the tests, you want your test to be repeatable, and not just repeatable in certain environment. Ideally, you want your test to be repeatable across all the systems where you run. Right, so on my laptop, on Cora's laptop, on your colleague's laptop, whether it is like Mac or Linux or Windows, on your CI/CD system, whether this is like, I don't know, GitHub Actions or anything else, you want the reproducibility of the tests, because that gives you that like shorter feedback cycle, because you can reproduce problems locally, and locally is the only place where you can fix issues, right? Unfortunately. As developers. Nobody else can fix issues, only developers. I personally feel it's very unfair, but that's how it is. Right, so we have a test suite, and we have this integration, and we're going to recreate a little bit of this configuration. So we need, let's run those tests. Let's run some of the tests. Let's run this test about the context loads and whether my application is there or not. And of course, it doesn't load because there is no database. So my application cannot wire things together because there is no database, and it of course cannot like figure out where is my database data in there because there is no database. So the simplest thing to create the ephemeral database for your tests is the following magical support for JDBC. What I can do, I can say that I want my Spring data source URL to be, this is normally where you do the JDBC URL. So I'm going to prepend that with the test containers suffix. So my JDBC URL will be JDBC TC, and then I can do PostgreSQL, and then say the tag is, this is very important, right? So Alpine. So what I'm saying is that when Spring will go and ask, like, who can handle this JDBC URL? No normal driver will say yes, because they don't know what TC is doing there. But the test containers driver will be like, yes, I can do that. They will take that information, they will take that string, and see that, oh, you want a Postgres. They will create the container for you, and they will wire it back into your Spring application, and they will give the control to the actual Postgres driver. So now, with this one simple configuration, I can run this test, and if there are no typos in that string, the test should pass. So now we have the actual integration tests in a Spring application that wires, creates the Postgres database. Why are we running all the tests? I don't want all the tests. I just want one, please. Look at the context load. Don't look at the other ones. The other ones will fail, because there is not enough environment there. Stop. I just want one, please. Here, context load. Just this. Right? One test. We connect to Docker. We figure it out. We start the rook, which is the killer of the containers after the test. We do extensive cleanup. Imagine your test pass. You want to get rid of the containers. Imagine your test fail. You want to get rid of the containers, right? Because you want the repeatable tests. Imagine your test crash. What if the JVM crashes? Your laptop burns, and your Docker was running on the nearby machine. The containers will keep running, right? Because there is nothing to clean them up. Wrong. So we start a container called rook, and if it will not receive a signal from the tests, then after a certain timeout, it will clean up the containers running there. So even if there is no connection between the machines, the environment is cleaned up. This is very, very important. So now we have the green tests. Yay, congratulations. This is one of the best parts of being a developer, seeing green tests. Doesn't happen very often, but like you feel how you're like, yes, I'm doing a good job when you see the green tests. Unfortunately, after they write the next thing that you're going to do, you're going to run another test or take the new issue, and then you are in the world of struggle again. So now health endpoint. Will the health endpoint give us green? No, because it needs more than the database. It needs Redis. So let's create Redis. Let's create Redis here, and this is how you do it. This is what you normally would do. Static, generic container, and you're going to say, like, I want Redis, and this is the new generic container, And this is going to be a Redis. What's the Redis? What Redis thing? 6 Alpine. How great is that? Did you see that? Did you see that? And I'm going to expose the ports, and I know 6379. Do you know what that was? That was the integration of the IntelliJ IDEA with test containers. And they're like, we think test containers is important enough, so we're going to build the content assist on strings in the APIs for the test containers, right? So that means I can do things like that. I can click on this and go to the Docker Hub, to the Docker image, which is great, right? And I can also do things like content assist, or even here. I can just say, pull my Docker image from here. How great is that? This is pretty spectacular. Right, so we start Redis. We know that Redis is the network application. We're going to use that port there. Next, what do we need to do? Besides the configuring the container, 2 things. The lifecycle, we need to start this container. And the other thing, we need to make sure that our Spring application knows where that container runs, right? We can do that both with a pretty simple trick. Public static void setup me. And we're going to use a dynamic property registry situation, which is a magnificent integration from the Spring framework, right? So if we mark a method with the dynamic property source, what will happen is that this configuration will be used for the tests, which means that all the properties that we can add in this method will be more important than whatever properties are there in the application YAML or in your application properties. So here, what we can do, first we can start our thing. It's very important because I usually forget that. So we're going to start Redis, and we're going to say join. This is a convenience method. If we have more containers, this startables will start them in parallel. And then we're going to do registry add. And then how do we configure Redis? Spring Redis host. And where is Redis running? Redis, I don't know where it's running. I'm going to just get the host from the thing, right? Just like Quora showed us. And we're going to get the first port, this port, right? So this is the whole configuration that we need. 1 line for the declaration of the container, and 5 lines for making sure that Spring knows where the container is running. And I think this healthy should now return and show green, because we have the database and we have our Redis running, right? And no, there was no external configuration. I was literally just typing dot and allowing my IDE help me through the process of writing this extremely complex thing. So now we need Kafka. And this is where the modules from the ecosystem come in play. So if we look at our dependency trees there, right? We have the Testcontainers Kafka library pulled in. We have the other modules there, Red Panda, Postgres, K3s, MongoDB, MariaDB, Cassandra, Elasticsearch, ToxicPro. We don't need all of them here in this application, but I'm just showing you that you can have all those technologies running in Docker containers in seconds, literally, by just ingesting the library, right? So let's use Kafka. How do we do Kafka? Kafka container. And this is Kafka. And this is new Kafka container. Wait, not new float. Kafka container. And then we can just say Docker image name parse. And what's the name? Confluent Inc. CP Kafka. And then I know just this version works. Right? So this is the whole configuration that we need to declare the Kafka container. For people who said that they know how to run Kafka in the Docker, double check, right? You need to start, you need to configure like a bunch of properties. You need to figure out what to do with Zookeeper. You need to figure out how to configure Kafka to advertise the Bootstrap listeners, to advertise the listeners on the actual port you mapped from the outside on the host instead of whatever Kafka thinks by default. And you need to run like a bunch of commands to do so. Luckily, as an application developer, you don't need to know that. Somebody else actually took care of that and created a library for you. So now here I can just say Kafka, and I can just say start my Kafka and configure this. Who knows what the configuration property for Kafka is? Kafka, Bootstrap, servers. Who knows the format for that string? I don't. I know that it's exposed from the library. So somebody smarter than me created that. And this is the beauty of test containers, right? You get the libraries, you build abstractions, and you can build whatever. And your teammates, for example, can use the benefits of your thing. So I can run this now. I think now This is the glorious moment. We have the database, we have Redis, we have Kafka. I think we can run the whole test suite. Who thinks everything will run fine? Who thinks something will fail? It usually fails, to be honest, right? So for unknown reasons. But I think at this point, I think we're going to run fine. So the demo, what we showed. What did we show? We show how to use the modules, which is literally just add the library and create the instance of the appropriate classes. We showed how to wire that into Spring by using dynamic property source and overriding the static configuration with the dynamic configuration that you only have at runtime because you create the ephemeral environment at runtime. We showed the magic JDBC URL. You don't have to do this. You don't have to do this. You can do also the normal thing, static Postgres container, right? And then you can do once Postgres, new Postgres container. And then you can do Postgres, right? 14 Alpine. This is the same thing, right? You can do it manually like this. And then the only thing that you need to do is you need to not forget to start it, and you need to sort of the configuration for this, right? Redis tree, string, the whole data source URL. And this is what? This is Postgres. You already know the drill, right? Postgres get JDBC URL. Look, I'm not even writing the code, right? It's something else. My IDE is writing the code. So I need username. And this is get username. And this is get password. Think about this. How long would it take for you to create that environment for your tests without this? That's like at least like a day worth of work, including the meetings, probably 2 days. So we are literally saving quite a bit of time here. So we created our Postgres. How do we initialize the data right now? The database. How is it? How is it working?
File in there, maybe? Or?
No. So currently what we are doing is we are, where's my application YAML? So here, right? We rely on Spring to initialize our database. Because when we start Postgres, it's empty, right? There is nothing in there. So here the configuration is Spring, please initialize our database. Do you do that in production? Did you say yes? No. No, obviously not, right? You use other things. You're using either the data migration libraries like Flyway or Liquidbase, or you take sort of snapshots of data. So we need to somehow else configure that. So let's do that. Let's say Spring, please do not initialize our data. So now the test will obviously fail, right? Like if I run this, because now our Postgres here, it will start. We will create the Postgres database. We will wire it into the Spring application, but there will be no context. There will be no data, right? So how can we initialize that? One thing is the database migration libraries, but I wanted to show you a way how you can configure all the services in general, right? So in general, what you do is you provide some of the configuration files from the outside into the service, into the container. So that could be your database schema, for example, right? You can put it in. Or that could be your Kafka configuration setup. Or if you're using, I don't know, like an ingress controller or like a service mesh, you will have a YAML file that represents the configuration for this particular test. And you will need to put it into the container. So you can do this very, very easily in general. There is API to do everything that you can do with a container. So we're going to copy the file. With copy file the container, we're going to say mountable file, get my schema SQL. Is it correct? And we need to put it in a place, right? So schema exists. This is our, go away. Right, this is our schema. We're going to just create the table and put some test data in the thing, right? And we need to put it in the correct place in the container, which is, let me see, scripts. For Postgres and many, many other databases, this is usually the Docker entry point in the DB directory, from which, when the Postgres inside the Docker container will start, because it's declared by the image, it will look into that directory, and it will pull up all the scripts and create a database. So I just need to put this there. And voila. I think now, if I rerun this test that was failing, now it will run properly. Of course, if you're using the migration library, right, you don't need to do this.
Flyway or liquid base.
Yes, yes. But then this is a very educational example how you configure anything, not just a database. So we have a few minutes. We have a few minutes. Maybe we should do Flyway. Should we do Flyway? Do you think we'll have time to do Flyway?
Are there any questions? Question up there?
What about the CI/CD pipelines where run on Kubernetes? Testcontainers also need to be run on Kubernetes.
Yes, that's a great question. How about CI/CD pipelines? That's part of the question. And how about CI/CD pipelines that run in Kubernetes? So Testcontainers runs excellently in CI/CD. You want them to run in CI/CD because that's where you want to run all your tests, even more than locally, right? Because that's the ultimate truth. Testcontainers relies on having access to a compatible, API-compatible Docker environment. So if you don't have a Docker environment in your CI/CD platform, then that is an issue, right? Because there, you cannot start the containers. So it sort of loses half the point. So you need to expose a Docker environment there. Some platforms do that. For Kubernetes-based platforms, so one thing is it doesn't have to be a local Docker environment. So if you have a remote Docker daemon, this whole thing will work as well. Internally at Atomic Jar, what we are building is a product called Testcontainers Cloud, which allows to run Testcontainers tests without relying on the local Docker environment. So the containers will be spin up in the cloud. So that could be an alternative solution for Kubernetes. But you have to provide some sort of a Docker environment that is there. It doesn't have to be Docker desktop or the official Docker distributions. Anything that is Docker compatible will work locally as well. So I know people are running sometimes with Minikube, which is the local Kubernetes distribution that exposes Docker API, and it is a compatible environment. Some people run with that Docker. Some people run with Rancher desktop, which is alternative locally. But well, in CI, you need to figure out how to run Docker, right? Even if your CI runs sort of inside the Docker containers by itself, you still need to provide access to Docker because we imperatively give commands like give me a container, create me this and that. And actually, since that's a good question, right? So we don't just run and start containers. But what you can do more complex things. For example, you can do, forget the data initialization. This is more interesting. You can have networks. You can have complex topologies of things where you can say, for example, put my Redis on the network with network, wait, stop, network, right? And what I can do, I can, for example, create the Toxi proxy container. Who knows what the Toxi proxy is? It's a Docker image by Shopify. So this is, wait, Shopify Toxi proxy. And this is 2.1.0. I think this version should work, right? So we're going to create a Toxi proxy container. And we're going to put it on the same network as Redis. And then, so as the name shows, it's a proxy, but it's also a toxic proxy. So what we can use that is to do complex things with our networks. For example, to cut the network access to whatever we're proxying to, or introduce latency, or drop some requests, or introduce jitter. So what we can use, we can build complex topologies of this within the network environment, shared by the running in the same Docker container. And then we're going to have our application use that Redis, not directly, but via the Toxi proxy. And in our tests, we can mess up with that and see if our application is resilient enough to outlive, for example, a small network outage, or if our Redis is slow.
Probably the easiest way to do chaos testing.
Right. Yeah, probably it is. So we're going to start toxic proxy, and we're going to say, toxic proxy, give me the proxy for Redis. And what was the port? 6379, right? So this is our Redis 1. I'm great with variable names.
The other interesting thing to note here is that everything is getting shifted left, right? So if normally you would rely on the platform to be able to introduce chaos and testing, that would be after a lot of development work, but you can actually do this now on your laptop very early on.
Yes, your laptop becomes a staging environment where you can run complex integration tests and actually verify that your application works with the technologies that you're going to run in production, right? It doesn't have to be like a random Postgres database that you downloaded 2 years ago, and then you're still using that because you never bothered to update, right? You can literally run your tests against the particular database version that you're going to be running in production. Or if you're building any sort of libraries that need to work with multiple things, or if you are preparing to an update, so say Postgres 15 comes out, might be out already, I don't know, but like imagine that you're preparing to migrate to Postgres 15. How you can verify that your application still works, right? You change the string, you run your tests, and if your tests pass, that means that your application is ready to work with that particular version of the technology, or that your test coverage is not so great and you've been a little bit naughty with how you run your tests and how you write your tests. Right, so we have just a few minutes. Just let's do the toxic proxy, right? So let's run this test. Which test do you want to run? We wanted to run this ratings, right? Ratings. This should pass. And I want you to look at the timings, how much time it takes for this test does like 5 requests that need to propagate through Kafka. So all in all, I think it takes around 5 seconds because the application is just so slow to respond to the requests. But around 5 seconds it should run, right? So now what we're going to do with our proxy, right? So here, now we configure our registry to go through the proxy, and what we can do, we can say Redis 1, toxics, latency, right? And we can say the downstream direction, please have 5 seconds latency at every interaction, right? So now, if I run this test again, will it work? Who thinks it will fail? Who thinks it will work? Who is completely lost? So I think it might fail because there might be the default timeout for 5 seconds for accessing Redis. So I think if I put 7 seconds there, it will definitely fail. But maybe not. But it will clearly run much longer than before because, oh, it failed. Oh my God, why? Because Redis is not available because we put too long of a timeout. Let's do 2 seconds. So now that was 5 before. Now every interaction will be like 2 seconds longer. So I think now this test will pass and it will take around 20 seconds to run because our Redis is now so slow.
But which is informative about how resilient your application is and what mitigation factors you might want to incorporate into your application based on this information, right?
Yeah.
So that's really useful information.
And think about the possibilities. You, as a developer, can create all kinds of abstractions to feed to the other people on your team. I can create an abstraction that says I'm a Redis container, but inside is actually 2 containers, a Redis and a toxic proxy. And I'm going to give that to Quora.
So be careful when you get container images from Oleg.
Quora will integrate with all the Spring projects that use Redis in all the tests. But under the hood, I can influence that all the projects are tested with the resiliency to slow Redis or to connection network cuts or anything. So if you're working somewhere on the
for edge with lower bandwidth, I mean it's really useful for a lot of cases.
Yeah. And if you are on the platform development team or you are responsible for developer experience at your companies and you want them to write tests, proper tests, and we're going to introduce chaos testing because our applications have not been very resilient and we need to do better, you can give them the library that does that under the hood and everything will be pretty great. Right. So those were the demos that we want to show.
Question? What was so? I think the question has to do with whether the stuff we heard in the morning about native images is, will it make this faster in terms of?
Just string images from test container.
Like, could you use this to do a speed test between? I mean, this will test containers will start anything that can start as a container. So if you have a native image, then test container should be able to start that. It doesn't really care what's inside the container.
Yeah.
As long as it's compatible with a Docker runtime, it'll start up the container, and then you can run tests against it. So does that answer your question? Does it? Okay.
So I think in general, for native images, integration tests are even better than your small unit tests, because then you don't introduce anything into your application or test class path, right? You can build your image, you can put it in a Docker container, it will start in no time. You can hit it with the request. So here, instead of just having, say, in my test, instead of having those dependencies, what I will have one more generic container, which is my native image. And then since my test is actually like sending HTTP traffic, so here, where I configure this, instead of saying like, oh, use my local server port, which is where my Spring application has been running during the test, right? I will just say use the port of the Docker container where my native image is starting, right? And we'll use my whole integration test suite and verify that my application in the Java mode and in the native image mode will work the same, and then it will be all universally pretty great.
Awesome.
Right.
Thank you. Oh, you wanted to show the QR code?
Oh, yeah.
Okay, we're going to show you one. We're going to take one more second to give you something for your own benefit.
So here, I didn't run Docker on my machine, right? I'm not sure that all the images run on my M1 Mac. Obviously, I used the Testcontainers cloud here, and all the Docker containers were running in the cloud instead of running local in my machine, which is great. Reduces the load on my machine, and so on. So this is one thing that I would love to show to you and share with you. It's currently, Testcontainers Cloud is in the private beta, so there is no open sign up yet. We're working on that, but if you really use test containers and if you would like to try Testcontainers Cloud, then you can skip the line of the private beta, and you can go register, file that form, and I will personally ping the person responsible sending the invitations to give them to you, and then you can try it, and send me all the feedback about whether you like it or not. So thank you very much. Thank you, Cora.
Thank you.
Yeah.
That was fun. Awesome.